triangles. One is based on the angles. What kind of angles does this triangle have? Acute. If all three angles are acute, then the triangle is acute. Okay? And if this triangle has one, what kind of angle is that? Then this would be a... Notice these two angles are acute, but if there's one right angle, the triangle is a right triangle. Okay, is it possible for a triangle to have two right angles? Shh. Shh, guys, pay attention.
No.
Hank, James, pay attention. Is it possible for a triangle to have two right angles?
No.
No. What do the angles in a triangle have to add up to?
180.
180. So if you have two 90-degree angles, that doesn't leave anything for the third. It's impossible to make a triangle with two right angles. Okay. And what's the third triangle based on the angles?
Obtuse.
Obtuse. If it has one obtuse angle, put your pencils down, boys.
Yes, sir.
Then it is an obtuse triangle. Is it possible to have two obtuse angles in your triangle?
No. Yes.
No. Two angles bigger than 90? No, that would not make a triangle. Okay, so that's based on the angles. You can also name triangles based on the sides. If all three sides are equal, you guys remember this one? It's a what? Equilateral. Okay, the word equal is in it, so most people remember that one. However, the next one, most people do not remember. It has two equal sides.
Isosceles.
It's called isosceles. It's weird because it's a Greek word.
You're Greek.
Isosceles is two equal sides. It could look like this. It could look like this. Could look like that. Okay, it could look like a lot of things. But anyways, isosceles. If it has no equal sides, there's a bunch of different ways you could draw it. This would be an example. You guys know this one? Scalene. Scalene has no equal sides. So this one's like small, medium, big. They're all different sizes. Okay, so triangles can be classified based on their angles and their sides. This triangle is not only is it equilateral, it's also acute because all these angles are less than 90. Actually, an equilateral triangle has equal angles as well. So what would each angle in an equilateral triangle have to be? 180 divided by 3, 60 degrees. So that's just an equilateral triangle. So equilaterals are always acute. I always have 60-degree angles. Isosceles could be acute isosceles. This is a right isosceles. Okay, and also it could be like turned, like it could be going that way. This is an obtuse isosceles. So they can look like a lot of different things. This is an obtuse scalene. So based on both. All right. In a right triangle, do you guys remember what the sides are called? Too big. The sides that are next to the right angles, A and B, are called legs. So leg, and the big side that's always across from the 90-degree angle, always opposite the 90-degree angle, is called the hypotenuse. Hypotenuse. So it's leg, hypotenuse. The big side for the big word. Okay, so that's in a right triangle. But you also have special names for, let me draw it better. An isosceles triangle also has special names for the sides. So the two equal sides in an isosceles are called legs. Not original, I guess. And the not leg sides are called...
The hypotenuse.
No. The base. Okay, the legs might not, in the picture, the legs could be on the bottom and the base could be on top. It's just the two equal sides are legs. Like it could be upside down like that or sideways or whatever. Still the legs. Okay, so this angle up top, you might remember this from like when we did pyramids. They call this the vertex angle, which is a terrible name because all corner points are called a vertex, vertices. But this is the vertex angle, special I guess. These two down here would be called base angles. Okay, notice I'm putting one mark on these to show that these two are congruent. Actually, when I put one arc down here, that means these two angles are congruent as well. So on the equilateral, I put a mark on each. Isosceles, scalene, I put different marks to show they're different. Okay, you guys got that? All logged away in your brain? That might need to be emptied, sounds like. Don't push it all the way.
It's okay.
Okay, and one more thing, last thing. When you extend the side of well, it could be a triangle, it could be any shape. It creates an angle, and this angle outside here is called the exterior angle. Okay, so we got angles 1, 2, and 3 are interior angles, the angles of the triangle. They have to add up to 180, we know that, right? And then the angle outside here, we'll call it angle 4. What do I know about angle 3 and angle 4?
They're a linear pair.
They're a linear pair, which means they should add up to 180. They should be supplementary. These two should add up to 180 because they make a line together. And angle 3 and angle 1 and 2 should add up to 180 because they're a triangle. Which means that angle 1 and 2 must be the same thing as angle 4. Because 3 and 4 add up to 180, and 3 and 1 and 2 add up to 180. So angle 1 and angle 2 together must equal angle 4. It's called the exterior angle theorem. Is that what they called it? Yes, that is what they call it. Okay, the exterior angle theorem says an exterior angle is equal to the sum, quiet, the sum of the remote interior angles. What does remote mean? Nope, opposite. You guys heard of like a remote deserted island or something? Desert island?
What is it? That's
Remote means far away. You can change the channel from far away with a remote control. Far away. Okay, anyways, so an exterior angle is equal to the sum of the remote interior angles. You guys follow that?
Mm-hmm.
This and this add up to this. 3 is not remote. 3 is right next to it. These two would have to add up to 180. That's all we know about that. But anyway, that's called the exterior angle theorem. Okay. Now that is everything. Number 1. What kind of triangle? Classify the triangle based on its angles and sides. There's the picture. So based on the angles, what kind of triangle is it? Right. Okay, based on the sides, what kind of triangle is it?
Scalene.
Right, none of these sides are equal. This is like small, medium, big. So this is scalene. Okay, number 3. It's got all 3. Okay, so let's start with the angles. What kind of angles are all 3 of these?
Isosceles.
What kind of angles are these?
Oh, that's only 3. Equilateral. 60-degree angle.
they are less than 90, so they are what?
Lateral?
What kind of angles are less than 90 degrees?
Acute.
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 So this is an acute triangle, and yes, all the sides are equal, so based on the angles, it's acute. Based on the sides, it's equilateral. All equilateral triangles are acute.
I knew it.
60-degree angles. Okay, number 5 through 8, it says draw and mark a triangle illustrating each description. If such a triangle is not possible, explain why. So they're kind of implying one of these is not possible to draw. Is it possible to draw an acute scalene triangle? What's scalene mean?
All sides are uneven.
Unequal sides. So you it's kind of like drawing an equilateral triangle. You just make it like lopsided so that the sides aren't the same. So like you see what I'm saying there? Just kind of like tip it over a little bit. It's kind of hard to draw a perfect. Anyway, that would be an example. All those angles are acute, and all the sides are a little bit different. So that would be it. The end. It said mark the picture. That means if any sides are the same, we would like show which sides are the same. But none of those are the same. Number 7, obtuse isosceles. What's obtuse mean? It's a big angle. What does isosceles mean?
Two same sides?
Yeah. And the two sides that are the same are going to have to be around the obtuse angle because the third side is going to end up being bigger than those two. So it could look something like that. Okay, it could, like if we flipped it around, it might look like this. That would be the same thing. Okay, so one of the evens must not be possible then. Number 9, refer to triangle MTS in the picture on the right. Alright, do you guys remember what were the legs of an isosceles triangle? The equal sides. So in that picture on number 9, which sides are equal? Huh? T and M are points, not sides. So what was the side on the top?
Line TS and line MS.
Okay, line TS, line MS. So TS, those are like line segments, right? So put a little segment symbol on top. Yeah, if the letter's on a corner point, that means it's the point in the corner, not the line. So you have to say TS, MS. B, name the vertex angle. You guys remember, sorry. On A, they also asked for the base side. So, semicolon, what's the base? MT. Okay, the first question on B is what's the vertex angle? You guys remember what I said that was?
Very tip.
Well, it's the tip if the base is at the bottom. The vertex angle is the angle between the vertex that's between the two legs, the two equal sides. It's kind of like the tip of the arrowhead, you could say that. So on 9, what is the tip of the arrowhead?
40.
Well, not how many degrees it is, what's it called? Angle S. Okay, and then that says, and what are the base angles? Well, that's the other two angles in the picture. Angle M an angle T. The angles that are close to the base. C says, what do you notice about the base angles? So if you look at that picture, what do you notice about those two base angles? They are the same. Yeah, they're congruent, they're equal, something like that. Congruent's fine. Is that always true on an isosceles triangle? Yes, it is actually always true. We're not learning that yet, but they're kind of hinting towards what we will learn. Okay, on 10b, it says state the relationship between the sides of the right triangle. So I didn't mention this today, but we've talked about this in the past. What do we know about the sides of a right triangle? From like last year. Pythagorean theorem. A squared plus B squared equals C squared. Leg squared plus leg squared equals hypotenuse squared. In this case, the legs are like 3 and 4. So 3 squared plus 4 squared equals 5 squared. Yeah. So, and that is true. 3 squared plus 4 squared does equal 5 squared. Magic.
5 squared plus 6 squared equals 7 squared?
No, it doesn't. Very rare for that to actually work. Alright, and then on 11, we're just finding the missing angles, basically. So we got a 65, a 65, and we got these two angles. So, if this is 65 right here, how could I find this angle?
65.
This angle right here. Corbin, how can I find this angle?
By adding 65. No.
No, don't say what Hank said. He got it wrong. He wasn't looking. What do we know about these two angles?
Hey, not you.
Yes, they're linear. They make a line together. So they have to add up to 180. So how do I find this angle?
180 minus 65.
Yep. Oh boy, where was that? I guess it's attached. 180 minus 65 is 115. Okay, somebody else. Carter, how can I find angle A up there?
Isn't it adding 265s and then minus 180?
Yep. So these three have to add up to 180. So 65 plus 65 make 130, and if we can take that away from 180, that would give us angle A. Here's one way you could write it. 65 plus 65. Take that away from 180, and you get 50 degrees. So what do they ask for? They say measurement of angle A, and we just said that was 50 degrees. And then they said, what's the measurement of ACD? And that was ACD, that was this one right here, 115. All right, 140. Somebody wants to get in. All right, K. Do you guys know what this means when they put one arc here and one arc here? Anybody? Ashley? You know what this means? Okay, that means these two angles have to be the same. So Brian, if this is 140, how could I find this angle?
Is it a linear pair?
Yeah.
Would it also perchance be?
No. Okay, these two angles together make a straight line, straight angle.
Yeah.
How many degrees are in a straight angle? 180.
So there's 180 minus
180 minus 140. So this one would be 40 degrees. If this one is 40 degrees, what's this one? 40 degrees. How did I know that? Because they put one arc here and one arc there. That means they're the same angle. Okay, how could I, Luke, how could I find angle K up here?
Do 40 plus 48.
That's a 40 also.
Oh, do 40 plus 40 and subtract that 180.
Yeah. 40 plus 40, take that away from 180. So that 40 and 40 are 80. 180 minus 80. Okay, so the book says, what's the measurement of angle KIH? Which one is KIH?
140.
No. K I H. No. K I H. What measurement is that? 40. Okay, and then it says, what's the measurement of angle K?
100.
Yeah, 100. Why did they use 3 letters on the first angle and 1 letter on the second angle? Why did they use 3 letters to name this angle, but 1 letter to name this angle?
Because KH is completely different angle, isn't it?
No. Okay. Because at this vertex I, there are 2 different angles. So you can't just call this angle I, because which angle are you referring to? So you have to use 3 letters. But angle K, there's only 1 angle up here, at vertex K. So angle K is clear what angle you're referring to. All right. 15. Okay, we got x minus 60, x minus 20, element O. All right, what do we know about these angles? Okay, what kind of angle is angle X up here? Remember what I called it? If it's outside the triangle? Exterior angle. What was the trick we learned about exterior angles? They equal, let me go back to it real quick. Exterior angles are equal to the sum of the remote interior angles. Like angle 4 is equal to angle 1 plus angle 2. So if X is an exterior angle, gosh, where is it? Then it is equal to the sum of its remote interior angles. So remote means the ones that are farther away. So X equals the sum of these two. So X minus 60 plus x minus 20 equals x. Oh boy. So how do I simplify this? How do I solve? What do I do? Like terms. X plus x, or 2x, minus 60 plus minus 20, negative 80, equals x. Now, what do I do when we have x's on both sides?
Subtract.
Yeah, we're going to get rid of them on one side. So if I subtract 2x, that gets rid of that. So x minus 2x is negative 1x. So what's x going to equal? 80. Okay, if x is 80, then what's this angle right here going to be? 80. We just said x is 80 degrees. Okay, what's this angle down here going to be? It's at x minus 60, so what's 20? Because it's 80 minus 60, so it's 20. What's this angle going to be? Yeah, 80 minus 20 is 60. And how could I find this angle right here?
180 miles.
Right. These two together should add up to 180. 180 minus 80 is 100. Okay, so basically these are all the questions they're asking. The first question is, what's the measurement of ONL? Yeah, that was the first angle we filled in. ONL, right there. ONL. Is 80. Brianna, what's the measurement of angle L? L is 20. And then, let me guess, ask M next. Angle M, Lauren, what would that be? M equals 60. And then it says measurement of angle L in M. Toby, what would that be? Measurement of angle L in M. So do you see L, M, and N on the picture? Oh, I said the wrong word. L, N, M. Okay, so if you follow that path, L, N, M. No, it's this angle right here. Whoops. It's this angle right here. Between these two. So what would that be? You see it? The angle right here is what?
I have no clue.
Okay, the angle is between the two sides. Here are the two sides. So what's that angle in this picture?
100.
See it? Okay, what would Toby, what would this angle right here be called?
80.
No, that's how many degrees it is, but what's the name of the angle?
180.
No.
Oh, the name L. Oh no.
Try again. What would it be called?
LND.
Yeah, except for that's an O. It's a sloppy O.
That's an O. That looks right.
Well, yeah. Okay, anyways, 100 degrees. Okay. Wasn't Hunter gone Monday too?
It's 180. No, he was.
He's gone, he came, and he left again.
I hear rumbling.
Okay. 17, in my book it's really hard to read this. Your guys' book looks better than mine. Actually, I might need to borrow somebody's book
You
here.
can borrow mine.
Okay, these are the same questions, they're just inside of a picture of a, real thing. D, okay, it's A, B, C, D, alright,
There's like a P.
alright, I'm good.
Thank you. very
Now,
much.
okay, it says find measurement of DBC. Alright, Carter DC angle DBC in there. How would we find that angle? DBC, so it's right here. How would we find that angle?
So, the sides right next to the 130
Yes. Together, yeah, they have to make 180. They make a straight angle together. So 180 minus 130 is 50, and then it says find the measure of angle BCD. James, what would that be?
In measurement of this, that is 90.
90-degree angle. And it says BDC. Let's see. Hank, what would that be?
40 degrees.
Guys, pay attention. Huh?
40 degrees.
They did what? Okay. Did you say the answer?
40 degrees.
Yeah. This is 90, this is 50. That makes 140. So what does this one have to be? The difference between 180, how about every time you guys talk, I'll just ask you the next question. That's how we'll do it. Okay, got it? So it's 40 degrees. All right. Was there one more question? Was that it? Was that? Okay. I'm in on that problem. 21, state the measure of the exterior angles to angle ABC. Okay. Alright, so it says ABC 60, 40, 80. Okay, an exterior angle is when you extend one of these sides. So you could like extend this side for the exterior angle, or you could extend that one. But either way, you get kind of the same angle right there. So what would the exterior angle at vertex A, what would this be?
60?
No. 60 is the interior angle. We want the exterior angle. So if it's 60 in here, what's it going to be out there? Yeah, 120. Together, they make a straight line. They have to add up to 180. So 180 minus 60 is 120. So, how did they label this? Oh, it's just A, B, C, and D. Okay. So, at vertex A, the exterior angle is 120. Miranda, what would this exterior angle be over here? No. Okay, what do we know about these two angles together? They make a straight line, so what should they be all together? Huh? A straight angle is 180 degrees. So if this is 40 of it, how could we find this part? Right, 180 minus 40 is 140. Okay, Ashley, how about up here? I make an exterior angle, what's that angle gonna be? 100, she said. Yeah, 180 minus 80, 100 degrees. Okay, 23. Where would you find the largest exterior angle of a triangle? So we kind of refer back to 21 on this. Which of these is the largest? Why is B the largest exterior? Why is B the largest exterior angle in this triangle?
Because it's linear pairs, the biggest out of all the linear pairs.
Hmm?
The exterior angle on it is the largest.
Right. Why was it at that angle and not the rest of them?
Because it's it has the smallest interior angle.
Right. If you have to do 180 minus the interior angle, the smaller the interior angle is, the larger the exterior angle is. Because they have to add up to 180. So the largest exterior angle is found adjacent to the smallest, I'll just say next to the smallest interior angle. And where would the smallest exterior angle be found?
Next to the largest one.
Next to the largest interior angle. Let's see how the book said it. The book said adjacent to the triangle's smallest angle. Yeah, that's pretty much it. Alright. Or did I say wrong? Look at 25. Is it? Yeah. We'll stop there, that's fine. That took a lot of time. Or maybe we'll finish tomorrow. Well, either way, we'll say that we'll grade this on Friday since today's Thursday, or Wednesday, I mean.